Hello everyone. Today we will learn how to use Cognito as an API gateway authorizer. First, we will briefly talk about system design diagram, then see what services we provision on the cloud using AWS CDK. Then lastly, we will look at the client code that is built with Next.js framework. Starting by system design diagram, what we have here is Cognito, API Gateway, and Lambda services. Cognito is responsible for managing and storing user identities. Today we will configure a Cognito client to work with user email and password, but it also supports phone number and third-party identity providers such as Google and Facebook. We directly talk with Cognito for all user-related actions, such as signing up, logging in, changing user settings, or recovering the account. All of this managed directly by Cognito service, and this is the reason why we use a managed service. Otherwise, we would have to implement all of these mentioned features. The process will start with clients sending a login request to the Cognito API. Once authentication is successful, it will receive a JSON web token. Next, the client will make a request to the API gateway, including this token in the authorization header. The API gateway will then communicate with Cognito to verify the JSON web token, determining whether to allow or deny access to the requested resource. If access is allowed, a request will be directed to Lambda alongside with a payload containing user identity. Lambda can leverage this user identity as it please. Later in the video, I will show you an example of the payload with user identity. Let's dive into our infrastructure code. When we look at our app stack, we will see three constructs: Lambda, Cognito, and API construct. Starting with Lambda construct, it provisions one Lambda called example Lambda. Basic stuff moving forward. What we have next is Cognito construct, and it provisions two resources: user pool and user pool client. Pool client is gateway to the pool. It enables us to interact with the pool. You can have multiple pool clients, each with its own set of permissions and access scope to the pool. For example, we can create another pool client with auth flow enabled, which defines explicitly what resources this pool can have. Moving forward, it's important to understand what user pool props does. Let's explain them one by one, starting with self-sign enabled set to true. It allows users to sign up by themselves. Otherwise, only admins can create new user in the pool using AWS console. Then we have sign-in aliases. It defines methods that users are able to use while signing up or logging in. In our case, it's set to email. We want them to use email, not phone, not username. Then we have auto verify set to email. So users can verify their account by email. Again, otherwise, admin would have to verify the user identity on the AWS console manually. Then we have user verification, represents the email content that will be sent to the user. We will see it shortly. And what we have here is standard and custom attributes. They can be used to hold arbitrary data on the user identity if you need it. Then we have password policy. You can tailor it according to your needs. For the client configuration, we only use Cognito as identity provider and enable authentication flow for username and password, aka email and password, and we set a time to live for the tokens. Moving to next construct, we have API. We use REST API as API type and configure the course settings in a way that won't create a problem for us in the dev stage. These permissions should be fine-tuned before going into production. Then we initialize our Cognito Authorizer, which is associated with the user pool that we defined on the Cognito construct. Caching can be enabled based on the incoming API address if you don't require to authorize every request. Then we add a root proxy to the REST API and backed it with our example lambda. We also make this proxy protected by associating it with the Authorizer. We have talked about every construct. Now it's time to deploy. Let's open our terminal and type npm command npm run deploy, and this will deploy your CDK stack to the cloud. I already done it, and what I want to do right now is to show you deployed stack. Our stack name is called Who has CDK examples, and if we open resources tab, we will see our construct names in grouped manner, and if we can find our pool link in the Cognito construct, we can open it in the new tab, and here is our user pool. Right now it doesn't have any user, but we will create it shortly. And if we look at app integration tab on the pool, we will see our created client. Let's open it, and this is the client that we created explicitly, and it reflects our settings. For example, for authentication flow, we enabled user and password, so it reflects in here. Now it's time to move on to the Next.js web client and create our first user. Next.js app resides on the front-end directory. It uses Next.js 13, latest version, and app directory. We have an app byte context that holds API URL and app user pool client ID in the state. Both of them can be obtained from the CloudFormation output. Let me show you how quickly. If we go back to our CDK stack, you will see outputs tab, and this will print your CloudFormation outputs. You need to copy and paste them to the context, and we have 4 pages: dashboard, sign up, login, and protected. Protected page will try to access protected resource on our API by sending AJAX requests. But without delving too much to code, first let's see our UI. I already started my Next.js dev server. We see our dashboard right now, and also I want to open network tab because I will show you some payloads later in the process. Let's head over to sign up page and create our first user in the user pool. I will type my own email and use a dummy password, and for the name I will type who has CDK examples and hit the sign up button, and it directly asked for the confirmation code. And let me show you incoming request, incoming email. Here it says this is your verification code. Also be notified this is our customization in the Cognito client. If we open our app Cognito construct again, you will see it reflects our configuration. So going back, let me grab verification code and confirm it, and it was successful. We signed up and confirmed our user successfully. So let's see our created user on the console, and we can see it's created with our email, and also it's confirmed. So we need to explicitly log in, because signing up doesn't return JSON web tokens. So I will type my dummy password again, and it's successfully logged in. Also our navigation bar is populated with the protected page. We can see returned JSON web tokens from the request. It's in the authentication result object. What we have is ID token, access token, and refresh token. ID token is the one that we will use while making requests to our API gateway, and access token is the one that can be used while making authenticated requests to the Cognito API. So if I open our system design diagram again, so let's say you will change user settings, so you need to make API request to the Cognito, so you will use access token. But if you want to make request to the our API gateway, you will use ID token in the authorization header. That's the difference between them. And last token type is refresh token. As the name reflects, it can be used to refresh ID and access token. Its time to live is longer than other tokens. So to not to interrupt user session, you can use refresh token if others token expired. At this point, I want to take time and look at the source code of our pages. If we start with sign up page, we see on the if we click on sign up button, we will call sign function, and it utilizes sign up method on the Cognito provider. All of other components also utilize Cognito provider. For example, for confirmation, it utilizes confirm sign up method, or login page utilize initiate out on the Cognito provider class. And Cognito provider class is distributed through app context to the React function components, and it follows a singleton pattern. It initialized once app is started, and it's imported from AWS SDK. Now we can access our protected page on the web client. Right now we are on the dashboard page and we have obtained JSON Web Tokens, and if I click protected page, it will make request to our API. This is our API endpoint and this is our protected resource, and we can see on the request headers authorization value is sent. This is our ID token that's obtained from Cognito, and request was successful and response is shown on the page. As promised, let me show you request payload that reached to Lambda. We're going back to our CDK stack and see our resources and open our Lambda. Then we will look at CloudWatch logs. It should be on the monitor tab, and if we view CloudWatch logs, our Lambda will print every incoming request payload, so it will be shown here. This is the latest payload, and if I expand it, you can see header payload, and there should be a request context in here. This is the populated by Cognito, and we can see on the claim object that our email and our name, all of it is populated by Cognito. Now let's test our protected endpoint without authorization header, and witness it will return 403. So if I hard refresh our page, we will lose context state, meaning tokens, and Next.js will redirect us to the home page. So let's try it. I clicked on hard refresh, and as we can see on network tab, our endpoint is returned 403 because we didn't include authorization value because of we didn't have anything to put in there. To recap what we have done so far, we created an user pool and pool client in the Cognito and associated it with the API to protect our resources, and we done this using infrastructure as code. Then we used web client to test our protected API endpoint, and we also utilized AWS SDK for this, and I will share the repo link in the description. It will include everything, and I hope you have learned something from this video, and see you next time.